Dear friends, welcome to my video on quantum computing explained for beginners. Kindly click on the CC button for subtitles. On quantum computing is an exciting and fast-evolving field that promises to revolutionize the way we process information. Unlike traditional computers, which use bits to represent data as zeros or ones, quantum computers rely on quantum bits or qubits. These qubits harness the principles of quantum mechanics, such as superposition and entanglement, to perform complex calculations much faster than classical computers. But what does this mean, and how does it work? Let's break it down in simple terms for beginners. What is a quantum bit, qubit? In classical computing, a bit can be either a 0 or a 1, like a light switch that is either off or on. In quantum computing, a qubit can exist in multiple states at once due to a property called superposition. This means that a qubit can be both 0 and 1 simultaneously. Imagine spinning a coin. While it's in the air, it's neither heads nor tails but rather in a state of both. Once you measure the coin, it collapses to either heads or tails. Similarly, when a qubit is measured, it collapses into either a 0 or a 1. Superposition and its power. Superposition allows quantum computers to process vast amounts of information at once. While a classical computer processes data linearly, quantum computers can handle multiple possibilities simultaneously. This feature dramatically increases the speed and capability of quantum computers for solving certain complex problems. For instance, searching through a massive database or solving intricate mathematical puzzles becomes exponentially faster with quantum computing. Quantum entanglement, the secret sauce. Another fascinating concept in quantum computing is entanglement. When qubits become entangled, the state of one qubit is directly related to the state of another, even if they are far apart. This spooky action, as Albert Einstein famously called it, enables qubits to work together in ways that classical bits cannot. Changes to one entangled qubit will instantly affect the other, allowing quantum computers to perform coordinated operations with exceptional speed. Quantum gates and algorithms. Just like classical computers use logic gates, and, or not, to process information, quantum computers use quantum gates. These gates manipulate qubits and their quantum states to perform computations. Quantum algorithms, such as Shor's algorithm for factoring large numbers or Grover's algorithm for searching unsorted data, showcase the incredible potential of quantum computing. These algorithms can solve problems in seconds that would take classical computers thousands of years. The future of quantum computing. Quantum computing is still in its early stages, but it has the potential to transform industries like cryptography, drug discovery, and artificial intelligence. For example, current encryption methods may become obsolete because quantum computers could crack complex codes quickly. In healthcare, quantum computers could simulate molecular structures and help design new medicines much faster than we can today. Final thoughts. While we are still years away from having fully functional quantum computers that can outperform classical ones on a large scale, the potential is undeniable. As scientists and engineers continue to make breakthroughs, quantum computing will likely become a key technology in solving some of the world's most complex challenges. For beginners, understanding the basics of quantum computing, qubits, superposition, entanglement, and quantum gates, opens the door to a world of incredible possibilities. As we look to the future, it's clear that quantum computing holds the key to a technological revolution. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.